Just finished our lessons about radicals and reducing them in operations. Now let's see how they work with quadratics. Remember, when we're going to solve a quadratic, it's supposed to be in standard form. That means it needs to be set equal to 0. This is not set equal to 0, so we have to subtract 4w squared and move it to this side, minus 4w squared. These cancel and give us our 0. This comes straight down, minus 6w, and 6 and negative 4 give us 2w squared. Now we are ready to start to use our quadratic equation, so we always have side work. All right, we need to find A, B, and C. So A is 2, B is negative 6, and C is 3. When we do our side work, we're calculating the discriminant. Remember our quadratic formula? I hope so. It's important here. B squared minus 4AC. So B is negative 6 squared minus 4 times 2 times 3. So here we have is a 36. And then, of course, guys, please be careful in your calculators. You have negative 4 times 2 times 3. Gives you negative 24. You add them together and you have 12. Now remember, this is under a square root. And what did we learn last class? This can be reduced. You can rewrite this as the square root of 4 times 3. Right? We can take the square root of 4. It becomes 2. What's left in the radical? Square root of 3. 2 times the square root of 3. So now we can go back into our quadratic formula and rewrite this as our discriminant. So we had, what was it, negative b plus or minus the square root of all of this, negative 6 squared minus 4 times 2 times 3, all over 2a. But now we know that all of this is equal to this. You have 2 square roots of 3 plus or minus 6 over 4. And our last step is we can realize if you look at this, these three numbers reduce. They all have 2 in common. 2 goes into 6 3 times. 2 goes into 2 once, so the only thing left is the square root of 3. And 2 goes into 4 2 times. And like that, you've been able to solve this and reduce radicals. Again, look at this one. Same thing, not in standard form. We have to subtract 2. T squared. And then we copy everything else down. And it's set equal to 0. Now it's in standard form. Now we can write our equation. The opposite of b plus or minus the square root of b squared minus 4ac. All over 2a. And our side work begins. We need to figure out a, b, and c, which is 3, 12, and 5. So b is 12.
Ms. Lavac and Ms. Christensen, can you please come up to the main office, please? Thank you.
12, 3, 3, and c is 5. Great. Our side work, b squared, so 12 squared is 144. Minus 4 times a times c. So negative 4 times 3 times 5. Negative 60. Great. Add them up. $84. Now, 84 is not a perfect square root, so we are going to have to split this up. Let's see. Which one of our perfect squares goes into 84 evenly? Not 16, not 9. Oh, it's 4. 4 times 21. The square root of 4 is 2. So that's 2 square roots of 21. Now we can rewrite this. The opposite of 12. So negative 12 plus or minus 2 square roots of 21. All over 6. And look, these three coefficients reduce. 2 goes into that. It's negative 6 times, plus or minus. That goes away. Square root of 21. All over 3. Like that. You've been able to reduce this. I want you guys to try the last example on your own and then do your homework. Have a wonderful day.